Hi everyone, this is Satishwali, professor from Civil Engineering Department. Today we are going to take a topic with the subject WSTE. We are going to take slow sand filter. So slow sand filter was first invented in England in 1829. This type of filters were widely used in 19th century before a rapid sand filter was introduced. So what we do, we draw directly the raw water from in plain sedimentation tank, okay, and we filter it, okay. So this is normally used in uh, s- small towns, okay, small villages, uh, because it's a low cost treatment and it is very effective treatment also. This is the reason why we use in smaller towns. So there are six major components, okay, of slow sand filter. We will see it one by one. So it's an enclosure tank, filter media, base material, under drain system, inlet and outlet arrangement, and other apparatus. So we'll see one by one. So first one is an enclosed tank. It is nothing but an water tight, okay, concrete machinery machinery tank. Okay, so the bed slope is around 1 in 100 towards in central drain, and the depth it varies from 2.5 to 3.5 meters. Okay, so the area of this tank is around 100 to 2000 square meters. The filter meter, so filter meter is this part, okay. So filter meter, the depth is around 90 to 110 centimeters in depth. It is placed over the gravel, okay, which supports this filter media itself. So effective depth, sorry, the effective size D10, it varies from 0.2 to 0.4 mm, and the informative coefficient D60 by D10, it varies from 1.2 to 2.5 or 3 itself. Okay, and the 15 centimeter of that sand layer is always resting on a uniform coarse grain size. Okay, and much of the filtration take place or the impurities are being removed at that top layer itself. So okay, so in this top layer only much of the purification take place, and we have got a finer particles at the top, and as we go at the bottom there are certain coarse particles, okay, in layer. Normally we use 3 to 5 layers over here. So the base material, so this is the base material, okay, so which supports the gravel. I'm sorry, um, so the base material, it consists of a gravel, okay, and which supports this filter media itself. So its depth is around 30 to 75 centimeters, okay, and okay, the finer size is at the top, okay, and the bottom size is always in coarser one, and you can see at the top 15 centimeters in depth. So size vary from 3 mm to 6 mm. Intermediate layers vary from 6 mm to 20 mm. Again from 20 to 40 mm. At the bottom they are of bigger size. So this size varies from 40 mm to 65 mm. So depth is around 15 centimeters. So this was about base material. So under drain system. So this is an under drain system. We have got a central drain over here. We have got a lateral drains over here, which has got porous. Okay. So always lateral drains has gotten slope towards an main drain itself. Okay. And they are being separated. The laterals are being separated 3 to 5 meters apart. Okay. So water is collected into this lateral, then it is being discharged to the main. Okay, so main, it has got an outlet. Sometimes we call it as an outlet well also, from where the water is being collected. Okay, Sometimes what happens here is again the main are so the main drains or can say the mains are being laid at the sides, and the laterals are soapy towards those main drain itself. Okay, so sometimes in some cases they do it. Inlet and outlet arrangement. The inlet and outlet arrangement. So inlet and outlet arrangement are in such a way that okay they should not disturb the sand layer in such a way that they arrange inlet and outlet arrangement. Okay, so in inlet, no, the raw water tend to get in from the plain sedimentation tank without disturbing the the filter media itself. Then it goes out. Okay, so outlet is constructed uh, to that of a main drain. Okay, and there is an adjustable telescope which is being used to control or to have a constant discharge. So we can see in this diagram you have got an adjustable telescope over here. Okay, adjustable, and we have got an automated valves, so which control the discharge of inlet as well as outlet. Other apparatus. So other apparatus, these are those apparatus which help these slow sand filters to function properly. Okay, sometimes there will be some air bubbles which will be in the filter media. Those things has to be removed out so that efficient working of filter should take place. Okay, and central depth controllers are being used, so those also help in functioning of slow sand filters. Flow meters are used. Okay, gauge meters are being used to measure the head losses. So if there is a negative head more, what it indicates there is that key the filter is not working properly. So you need to go for a cleaning operation. Okay, so those indicators should be installed in your slow sand filters, and these are those other apparatus which help you in proper functioning of slow sand filter. Some keynote about slow sand filter. So those are nothing but it kills around 98 to 99% of the bacteria. It removes suspended impurities. Okay, and it reduces the turbidity around 1 NTU. Again, slow sand filters can remove odor, taste, and color, but it can't kill pathogenic bacteria. It consumes a large space. The rate of filtration is very much slower here. You need to have a certain arrangement in such a way that you should stop this algae growth. If algae growth is there, your slow sand filter will not work properly, and there should not be any flocculation over here. Fog should not be developed. Okay, and we should never dose and coagulant in slow sand filter. Okay, since it clogs quickly the beds itself. So if it clogs quickly the bed, your filtration rates tend to get reduced. Your filter will not work properly. Next one, other operation and cleaning. Operation and cleaning process of this slow sand filter. So operation is nothing but it is an inlet. From inlet the water goes through the filter media. It is being distributed uniformly, and water tend to percolate through these sand layers, get purified, get into the lateral drains, okay, which supports the gravel bed. Lateral drains move towards the main drain from where the water is being collected. The pure water is being collected from that outlet itself. The cleaning operation as this lateral drain doesn't support any backwash. So there is a manual cleaning involved in slow sand filter. It's a very tedious. So what we need to scrapping it. You need to remove it layer by layer of 1.5 to 3 centimeters. Okay, you need to wash it. You need to clean it with respect to good water. Okay, and till the depth of the sand reduces to 40 mm or so. Again, then you need to add more sand. It is quite laborious. Okay, because many labor works are involved removing of that sand, cleaning it, putting back that sand. Okay, so it is quite an laborious work. But water quantity used for this cleaning purpose is very less as we compare to that of an rapid sand filter. Okay, so this is in cleaning operation. Next one, how a filter media should be in slow sand filter or in rapid sand filter. You can take mainly it is made of an quartz. Okay, it should be free from dust and other particles. It should be uniform size. It should be hard and resistive. So when we dip in hydrochloric acid for 24 hours, the weight loss should be we should not be more than 5%. Okay, so this is one of the major criteria. I use the word effective size over there. So what do you mean by that? Effective size of the sand is nothing but it's in measuring and expression. Okay, so that is nothing but effective size. When I meant to say the word D10 over there, so what do you mean by that? It may be defined as a size of sieve in mm through which 10% of the sand, or can say sand, I use the word, you can say the sample of the sand, okay, by mass will pass. So that is D10 means nothing but 10%. I use the word there uniformity coefficient. So what do you mean by uniformity coefficient? The uniformity coefficient, okay, uniformity is nothing but size or degree or the variation in size of a particle is measured and expressed. Okay, so this can be termed as uniformity coefficient. So, so what do you mean by D10 by D60 or D60 by D10? Okay, so it may be defined as a ratio of sieve. What is that? It's an ratio of sieve in mm through which 60% of the sample, so it is D60, 60% of the sample will be passing effective size of the sand. So that is we mean by an uniformity coefficient. Okay. So next one, filter medium. Okay. So here the gravel part. Okay. So gravel should be hard, durable. It should be free from dirt and impurities. Okay, properly laundered, and the density should be around 1600 kg per meter square. Okay. Sometimes anthraphile is being used as a filter media. So what is that? It is nothing but it's in cold stone. Okay, it doesn't have a smoke or flame when it is being burnt. It can be used also as a filter media. It is cheap and it has got a high rate of filtration. But this type of coal is not found in India itself. And as per as Central Public Health Research Institute Nagpur, it has been found that bitumen can be used as in filter media also. Okay, so this was all about slow sand filter. Thank you very much. Be safe. Okay.